The University of Sydney is located right in the heart of multicultural Sydney. It was founded in 1850 as Australia's first university. Students have been studying geology and geophysics here since the late 1800s. Some of Australia's most famous geologists have been educated here, including Sir Douglas Mawson, the well-known Antarctic explorer.
CTDS stands for the Centre for Translational Data Science, where the emphasis is most definitely on the word translational. The vision of CTDS is to transform the process of discovery in science by forming truly multidisciplinary partnerships by data scientists such as myself and domain scientists such as Dietmar.
EarthByte is Australia's largest e-research group. Our research is multidisciplinary, and our fundamental aim is to build a four-dimensional Earth model connecting solid Earth and surface processes through deep time.
The field of Earth science is rich in complex and multidimensional data, but this data becomes more scant the further we go back in geological time. The grand challenge is how to use this sparse but complex data to understand how the Earth has evolved for the last 2 billion years and the uncertainties surrounding that.
Our core philosophy is to build open source software and make open access data and model outputs available to the community.
The EarthByte and CTDS Alliance forms a unique team of geoscientists and data scientists who together are going to tackle the problem of what lies underneath Australia and how it got there.
I'm a sedimentologist. I have a special interest in marine sediments and the application of machine learning methods to large and complex sedimentological data sets. We recently produced a 3D digital globe of seafloor sediments. The globe incorporates descriptions of about 15,000 samples collected from the seafloor on seagoing voyages over many decades. The globe is an excellent research and teaching resource. It is fully interactive, it can be rotated, it can be tilted, there's a zoom function, and it can be viewed on any smart device by anyone in the world with access to the internet. The digital data set of seafloor sediments allows us to make the connection between sediments at the bottom of the sea and oceanographic parameters at the sea surface, such as salinity and temperature.
Here at the EarthByte Group and Basin Genesis Hub, we work tirelessly to bring together geological and geophysical data into models of Earth evolution. We develop and use the G-Plates plate reconstruction software that allows us to piece together the tectonic puzzle of Earth's history over hundreds of millions of years. We study the interplay between deep and shallow Earth processes using our open source software Badlands, which tracks the erosion of rocks upstream, the distribution of sediments across the river networks, leading to deposition in sedimentary basins. By linking the interplay of dynamic topography, sea level, and rainfall, we can actually track the evolution surfaces over deep geological time. Our vision is to build more realistic models of Earth evolution in deep time, which tells us something about Earth's past, but this also provides us insights into future challenges that we may face as a society, including resources, energy, climate change, and sea level rise.
Continental Lithosphere has a relatively thick crust. It's 40 kilometres thick. If you push it together by two continents colliding together, then you create a mountain range where India is crashing into Eurasia, and it's created this enormous Tibetan plateau. The Tibetan plateau will fall apart as soon as India stops moving northward, and it will fall apart just by gravity forcing it to spread and by erosion. If you pull it apart where the continents are rifting, the crust is thinned and you create a basin. Another good example of where the lithosphere is being pulled apart is in the Eastern Mediterranean, where the area occupied by Turkey is being stretched, the Aegean Sea between Greece and Turkey is being stretched, the whole area is subsiding.
The Basin Genesis Hub is a research group which is co-funded by the Australian Research Council and members of the industry. Our aim is to use the capability of supercomputers to simulate and understand the formation of sedimentary basins. We tap upon the power of computing programs, and what we do is to couple those programs to understand how the surface of the Earth evolved under the drive and the push of mental processes. We are contributing to the development of two key numerical codes. one called Underworld and the other one called Badland. And it is the coupling between these two codes that allows us to simulate the formation of those sedimentary basins.
Rifco is a model that simulates assemblages of coral over time for thousands of years. We use Bayesian inference via MCMC methods to model the free parameters that best describes the growth of the coral assemblages. In the case of Badlands, we use Bayesian inference via MCMC to model the free parameters such as erodibility and rainfall. The goal is to find the probability distribution for the free parameters such as rainfall and erodibility that gives the simulated topography that well describes the real topography.
The future of EarthByte is in developing an experimental planet, using data model fusion to unravel how our planet has evolved as a system. We aim to connect deep Earth to surface processes over geological time and over supercontinental cycles to understand how the deep Earth has driven environmental cycles and mineralization.